Welcome. In this video, I want to work a problem where we determine the power dissipation by resistors in a circuit with multiple resistors. It should be reasonably straightforward, but I want to work the example so you see how this is done. Let's begin. Now, here's the circuit. We have a 10-volt supply. It could be a battery, it could be a DC supply. 3 resistors, the 20, the 12, the 18. The 3 resistors are in series. We consider the current from the high side of the supply. It's going to flow through the circuit, through the first resistor, through the second resistor, through the third resistor, back into the battery. Series resistors, what goes in one is going to come out, go into the next, into the next. And remember, in series, everything has the same current. It may have different voltages, but the resistors will have the same current. What will that current be? Well, let's consider, we could just say you have 3 resistors in series. For series resistors, you simply add the values. So 20 plus 12 plus 18 ohms will equal, that's going to be 50 ohms. That's what those 3 resistors are equivalent to. Therefore, if I want to just illustrate by redrawing the circuit of the 10-volt supply, I can draw one resistor, which would be 50 ohms. Current goes through there. I know the Kirchhoff loop. If I were to travel around the loop, so I start here, travel around like that, I'm going to find 10 volts minus I times 50 ohms. Come back where we started, equal to 0. Remember, if you're traveling around the loop in the direction of the current, when you cross the resistor, voltage is going to decrease, minus I times R. So we'll find that the current, we can rearrange this, is simply 10 volts over 50 ohms just by rearranging that equation. 0.20 amp. That's the current through the circuit. So at this point, I can clean up this right here, the 50 ohm. We know that's the equivalent resistance. And I can write the current for each element. I said here, 0.2 amp. I'm going to have 0.20 ampere, 0.20 ampere, 0.20 ampere, and you can even say we have 0.20 amp flowing to the battery. Now, remember the current is flowing to the battery because charge passes to the battery, picks up energy. It takes that energy and it gets lost as heat in each resistor. So power is just the current, the charge over time. So it's the rate that the charge is flowing through there. The current is the rate the charge is flowing through there, the rate it's gaining energy from the battery, and that energy per time is the power. So let's again, clean this up some and work through different factors in calculating power. The first thing I like to do is consider this supply right here. That power supply delivers power to the circuit. I like to call that power delivered to the circuit. For that, I like to simply say, what's the current? What's the delta V of the supply? In this case, you see it's going to be 0.20 amp times 10 volt supply. It's going to be 2.0 watts. In other words, this thing is delivering 2 watts to the circuit. If I said how much energy is going to the circuit, you'd say, well, I need to know how long this is going on, because energy would be power times time. Power, the 2 watts, is the rate. Amount of energy, I need to know how long. So this thing, delivering power to the circuit, I call that P delivered, the power delivered to the circuit. Now, as the current flows through, let me just go ahead and write that equation I like to use there. So that's, I like to say I delta V. Well, that's the delta V of the supply. Or sometimes I use the epsilon. So when we use epsilon, then there's no doubt that refers to the supply. Delta V, here is understood that delta V is the 10 volt of the supply. What about for the resistor as current flows through it? Well, for power dissipated. Now, dissipated means scatter. When the resistor heats up from the current flowing through it, you cannot store that heat. That heat is all lost to the environment, to the air, whatever is in contact with the resistor. If it's hot enough, you're losing it radiatively. For that, power dissipation, I like to use the formula I squared R, because if you know the current through the resistor, you know its resistance, it's intuitively the power dissipated depends upon the current, depends upon the resistance. If you know the voltage across the resistance, you can also do that delta V squared over R. But I like this formula because it's closer to what's happening. The current flows through there. The collisions of electrons charged with the material of the resistor dissipates heat. So it's that current flow that dissipates the energy. So power dissipated, I squared R. So for this first one, we'll say 0.20 amp squared times 20 ohms. That is equal to 0.80 watts. That resistor. Next one has the same current. 0.20 amp squared times 12 ohms. That's equal to 0.48 watts. Now we got this resistor here, same current. The power dissipated, current squared, times 18 ohms. That's equal to 0.72 watts. So there you have a picture of all the power in the circuit. What's delivered from the supply, I like to use the current I times delta V of the supply. Let me just to be explicit there and write delta V supply. The power delivered. And we find that's 2 watts. For the resistors, there will be some problems, or more convenient to use another form, like if you know the voltage of the resistor across the resistor, you can use the delta V squared over R. But often it's more natural to solve for the current first. From the current, you can get the voltage, the I times R. But if you have the current, for the power dissipated, I like to use I squared R. So 0.2 amps squared, 20, get 0.8 watts, 0.48, 0.72. So now we have power delivered, (2 watts). The power dissipated, you heat the resistors and it loses the power. We have 3 resistors. There's 0.80 watt. There's 0.48 watt. Right, that's the second one. And then the third one, 0.72 watt. Of course, if you add those up, you get 2.00 watts. Okay, so this is a simple illustration. There are many ways to combine resistors and supplies and so forth. The point being, once you know the current through that resistor, divide the resistor. Series, parallel, however it's arranged, I squared R will give the power dissipated by that resistor. If you know the current through the supply, you tell how much it's delivering, that I delta V. Okay, so that is the end of the video, and I thank you for watching all the way to the end.